Hi everyone, welcome to the right-angled trigonometry review. So trigonometry is a branch of mathematics that deals with the relationships between angles and sides of triangles. And while it applies to all kinds of triangles, we begin with the most important one, the right-angled triangle. So here we have three right-angled triangles. Now note that they're all orientated slightly different. So this is something to be aware of. And you do just need to sort of really highlight to yourself where the right angle is in the shape, okay? Now that comes into play, it becomes important when we are labeling the sides of the triangle, okay? So there's three sides to our triangle. We have the hypotenuse, we have the adjacent, and we have the opposite. Okay, so the first thing you want to do in a question is label the sides of the triangle. Okay, so starting with the first, the hypotenuse, well, this is always opposite the right angle. So if you draw that straight line out from your right angle, you will always hit the hypotenuse, okay? I abbreviate this to the hype. Some people will just label it as H. That's fine, as long as you know that it's the hypotenuse. The hypotenuse is also the longest side. Okay, so then for the adjacent and the opposite. Now these two are actually interchangeable depending on the angle, the other angle that you were either given or the other angle that you need to find in the question. Okay, so let me give you a couple of examples. I'm just going to label another angle in each of these triangles to explain what I mean, okay? So let's start with the opposite, okay? So the opposite, the clue's in the name, it is opposite the angle, okay? So opposite the angle, okay? So we'll call that the op. Okay, which then means the final side of the triangle must be the adjacent. Okay, so we can abbreviate this to adj. Okay, really important to do this each time. Here's some practice for labeling the sides of the triangles. If you want to pause the video now, and then I will put up the answers in a moment. Okay guys, you can pause the video again here and check to see how you did. Okay, so within our right angle trigonometry, we have a saying that you may have heard before. Really important to remember. So, ka, toa. Okay, there are a number of rhymes that you can use to help remember this as well. But the reason why it's important is basically your S, C, and T at the beginning of each of these three letters. They stand for the trigonometry ratios. You can also see these on your calculator as well if you have a look. Okay, and they basically they use different sides of the triangle, which is why it's important to be able to label it correctly. Okay. We also have two different ways in which we use these ratios. So the two boxes that we have here, we have to find a missing side, and then we have to find a missing angle. You will also see sometimes these ratios written into little triangles like this. Sometimes that's more helpful for people. You've just got to find the way that suits you. Okay. So let's start with so. Okay, so that would be for finding a missing side, we would need to do sine of the angle, which we use the Greek letter of theta to denote, is equal to the opposite over the hypotenuse. Okay. Then we have cos, which is cosine of theta of the angle, is equal to the adjacent over the hypotenuse. And then we have tangent, or tan, of the angle theta is equal to the opposite over the adjacent. Okay, so those are the three that we would use to find a missing side. You will see in the questions that follow how to rearrange them differently depending on what it is that you need to find. And then we have to find a missing angle. Okay, so this time, instead of using the sin, cos, tan ratios, we actually use the inverse of sine and the inverse of cosine and the inverse of tangent to find an angle, okay? We're kind of working backwards ultimately. So when you look at your calculator, or if you're using Desmos, you will need to find the inverse ratio. So for sine, it's going to be sine with a little -1, and then within the brackets, you would put the opposite over the hypotenuse, and that will equal to theta, which is the angle. You would do the same thing for cosine, so inverse cosine, and then within the brackets, the adjacent over the hypotenuse, and that would equal to theta. And then same thing for inverse tan, is the opposite over the adjacent, and that will give you the angle theta. Okay, so just make a note of these. You do need to learn them. It will really help in your confidence within this topic, okay? I will admit that finding a missing angle is a much easier calculation to do than the other. But either way, learning the formulas will always help you. Okay, so the first question we are going to practice here is finding a missing side. Okay, so you can see the triangle we've got here. It is a right angle triangle. We have an angle labeled as 37 degrees. We have a side labeled as 11 centimeters, and we need to find x. So the first thing that I'm going to do is I'm going to label the sides, okay? So opposite my right angle, this is my hypotenuse, okay? Next to my angle that's labeled 37, this would be my adjacent. And then opposite the angle of 37 would be the opposite. Now, for this question, there's no measurement there, and it's not involved in my calculation. So I'm actually going to leave this one blank now so as to not confuse myself, okay? So the next step that I need to do is to decide which ratio I need to use, okay? So we've got our ratios on the left-hand side here. For good practice, I always write out my little saying, so SOHCAHTOA, okay? And then I'm going to tick off the sides that I've got. So I've got the adjacent, so let's tick the A's, and I'm trying to find the hypotenuse, so tick the H's, okay? The ratio that has both sides ticked is the ratio that you are going to use. So for this question, we're going to be using cosine. So I'm going to copy out my cosine ratio from the left-hand side here. So I know that cosine of the angle is equal to the adjacent over the hypotenuse. Okay, I'm going to substitute in what I know. So I know that the angle is 37, and I have the adjacent, which is 11, and I am going to divide that by the hypotenuse, which here is labeled as x. Okay, so now what we need to do is rearrange to find x, to make x the subject, basically. Okay, so different ways to do this. To explain what's going to happen to get x on its own, we are ultimately going to multiply both sides by x. Okay, that would give me, on the left-hand side, I would have x times cos 37 is equal to 11. And then I'm going to divide both sides by cos 37 to isolate x again and make it my subject. Okay, it's a nice little trick to kind of learn, is ultimately if your missing value is on the bottom of the fraction, you just kind of switch them out with each other. So we have x is equal to 11 divided by cos 37. You're going to pop that into your calculator at this point, and you would get that x is equal to 13.8 centimeters rounded to 1 decimal place. Okay, just be careful in any question that you get what This is going to be another example of finding a missing side, but this time I will show you what happens or the different rearranging when the missing side is on the top of the fraction rather than the bottom. Okay, so again, first thing to start with is labeling the sides. Okay, so here we've got the hypotenuse, which is 75 centimeters, and I've got the opposite. Okay, don't need the adjacent for this question. I can see that there's no measurement there, there's no variable there, so it's not involved in this question. So then I'm going to write out my SOHCAHTOA and I'm going to tick off the sides that we have. So we've got the opposite and we've got the hypotenuse. So here we're going to use in sine. So let me just write out the ratio. Sine theta is equal to the opposite over the hypotenuse. And then I'm going to substitute in what I know. So sine of 55 is equal to the opposite, which here is labeled as x, divided by 75. Okay, so we can see here that our unknown value is the numerator of the fraction. Okay, so to isolate this, I need to multiply both sides by 75. This will cancel out the denominator on the right hand side. Okay, so 75 multiplied by sine 55 is equal to x. Okay, at this point, you are going to grab your calculator. You are going to make sure that it is in degrees, and you're going to just pop that into your calculator, and you should get an answer of 61.4. So x is equal to 61.4 centimeters. Okay, again, just make sure that you're rounding correctly. If it asks you for one decimal place or an integer, just be careful with that. Okay, now we're on to an example of finding a missing angle. Okay, so this is the easier one. It's just a little less in terms of the number of steps. Okay, but you do start off the same way. So again, we want to label our sides. So here I have the opposite, and I also have the adjacent in this question. Okay, so SOHCAHTOA. Let's tick off what we have here. So we've got the opposite and I have the adjacent. Okay, so my ratio for this question is going to be tan. So inverse tan, because I'm finding an angle, and it's going to be the opposite over the adjacent, and that will tell me what theta is. Okay, so let's fill in what we know here. We know that the opposite is 12. We know that the adjacent is 9. I'm going to pop that into my calculator. And again, remember to put the inverse. Okay, so if you're using a scientific calculator, you need to press shift first. If you are using Desmos, then you should just have an alternative button to press. Okay, so when you pop this in, you should get an angle of 53.1, and remember that angles are measured in degrees, so just make sure you add that to your answer. Here is one final example of finding a missing angle using our trigonometry ratios. So again, we want to label the sides. So I have the opposite and I also have the hypotenuse. Okay, we write out our SOHCAHTOA, and then let's see what sides we have. So we have the opposite and we have the hypotenuse. So here we need to use sine. Now we are finding a missing angle, so we're using inverse sine. So let me just write out the ratio so that it's easy for me to substitute into. So I have inverse sine. I want the opposite, which is 42, divided by the hypotenuse, which is 48, and that is equal to theta. So you're going to pop that into your calculator. So again, remember to press the shift button if you're using a scientific calculator to make sure you get the inverse. And you will find that the angle is 61.04 degrees, okay? And we can approximate this to 61 degrees. Here are some mixed practice questions. Here are the answers to those previous questions. Let's just check to see how you've... For this question, immediately it's not as obvious what we need to do, so I'm going to go through this. You can see here that we don't have a right angled triangle, we just have a non-right angled triangle. We have two angles, so we can work out the third one, but it's not immediately obvious what we need to do, okay? But what we can do, which is going to help us, is we can split this triangle into two to create that right angle, okay? So I'm going to draw a line, my perpendicular height or my vertical height from the base up to the highest point, and I'm going to pop in those two right angles either side of that line, okay? So for the x millimeters that we're trying to calculate here, the missing side, for that right hand side triangle at the moment, I don't have enough information to be able to use one of my trigonometry ratios because I only have one angle that I know. I know that I know that the other angle is part of 71 degrees, but I don't know how much, okay? So we're going to need to focus on the left-hand side first of all, okay? Now I'm going to look at the angles of that bigger the whole triangle first of all. So we've got 71 degrees and we have 44 degrees, okay? That gives me a total of 115 degrees, okay? So angles in a triangle sum to 180 degrees. So if I subtract that 115, I can find that missing angle, which is going to be 65 degrees. So let me just fill that in as well. So we've got 65 degrees here. Okay, so if I look at this left-hand side triangle first and label the sides, well, I've got the hypotenuse, okay? And ultimately what I'm going to need to find is the perpendicular height, which for this left-hand triangle is going to be the opposite, okay? So using SOHCAHTOA, okay, we've got our hypotenuse and we've got our opposite, okay? So I'm going to be using the sine ratio and I am finding a missing side. So I need to use sine theta is equal to opposite over hypotenuse. So let me fill in what I know. I have sine of 65 is equal to the opposite over 12. Okay, I'm going to multiply both sides by 12. So we have 12 multiplied by sine 65. That's going to give my opposite. So just put that into your calculator. So my opposite is going to be 10.87569, and it does keep going. Now you might think at this point to round, okay, it's really, really important in a multi-step problem like this that you do not round until the end, because otherwise you will basically introduce calculation errors. Okay, so we're not going to round this just yet. We're going to round at the very end. But what I do have now is I have enough information to calculate the missing side, which is labeled x millimeters. Okay, so let me just kind of redraw what we have now. So we have our right angle. We've just worked out the opposite to be 10.87569 and so on. I know that this angle down here is 44 degrees and I'm trying to find this x millimeters. Okay, so what sides do I have? Well, I have the opposite And I also have the hypotenuse. Okay, so it is going to be the same ratio to be used as last time, just a different arrangement. Okay, so this time we have sine of 44 is equal to the opposite, which is this 10.87569, all divided by x. So I'm going to rearrange to make x my subject. So multiply by x on both sides first. So we have x times sine 44 is equal to 10.87569. And then we're going to divide both sides by sine 44. Okay, that's going to give me x is equal to 10.87569 divided by, what happened to my 7? Sine 44. Should have given myself more room. Divided by, pop this into your calculator, and you should get 15.65, which I'm going to round to 15.7 millimeters. And there you go, you can round at the very end, okay? Okay, here is a final practice question. If you would like to pause the video here, I will put up the answers in a second. Okay, so to work through the solution for this, the first thing I want to do here is find out my missing angle. So I've got 101 degrees, I've got 50 degrees. It gives me a total of 151 degrees. I know angles in a triangle sum to 180. So 180 take away 151 leaves me with 29 degrees. So let's fill in this angle here. We know that that's 29 degrees. And then I want to split my triangle into two right angled triangles. Okay, I'm going to focus on this left hand side triangle first of all. So I'm looking to find the opposite here. Okay, and I have the hypotenuse. Okay, so I am going to be using sine theta equals the opposite over the hypotenuse. So here we have sine 29, which is equal to the opposite over 23. So I can multiply both sides by 23. Okay, and that is going to give me 11.15 millimeters. Okay, so now moving on to that right hand side of the triangle. So let me just redraw that with what I know. Oops. Okay, so we've got our right angle here. We know that this is 11.15. I'm trying to find my hypotenuse, which here is x millimeters. And I know that this angle here is 50 degrees, okay? So I've got my opposite, and I'm trying to find the hypotenuse, so it's going to be sine again. So sine theta is equal to opposite over hypotenuse. So sine 50 is equal to 11.15 divided by x. Okay, so we're going to switch these out. So x is equal. Now what I'm actually going to do here is, instead of using the 11.15, okay, I'm going to go back to what it was previously and use that just to avoid any rounding errors. Okay, the 11.15 came from 23 multiplied by sine 29, okay, and then I'm going to divide that by the sine of 50, okay. You're going to pop that into your calculator, and you should be getting an answer of around 14.5, okay. So x is equal to 14.5 56 millimeters, okay, if we round that to 2 decimal places. Okay.